All right, so we've got Fluent project number 2 here, the wind tunnel with a plate that's at 0 degrees, 30 degrees, 60 degrees, and 90 degrees, and the different effects that it sees on that wind tunnel. So I'm going to share my screen here. Cool. All right, shoot. Let's go to Fluent here. So what I've done again, I hope I'm not going to lose any points for this. And if you decide to deduct points, when you post my grade, please put on the comments there not to do this, so I know not to do it again. Because this software doesn't run the fastest on my laptop, so I like to get it all done and then try and save everybody a little bit of time, so you're not sitting here watching shit compile for a long time. Refresh that simulation while we're here. My dog wanting to play with me at the same time. All right, so, well, that's running here. Oh, I guess I really put run. Start doing this again. Come on. I know this happened during the demo. No available licenses at this time. Super duper. Oh, looks like I got a license. All right, cool. So here we are. We got 4 different simulations that I set up here. With the first one here, the plate at 0 degrees. All right. We edit the geometry in design modeler, not space claim. So down here in the DM, we can see that I have 2 for A, 2 for B, 2 for C, 2 for D. So we'll go through that here in the first example that we did with the plate at 90 degrees. What I went ahead and did was I opened up the sketch, chose a rectangle, drew a rectangle. Once the rectangle was done, I came down to dimensions, chose general, picked the side of it here, modified it to 5 centimeters, picked the top of it, modified it to 50 centimeters. Right? Came up to concept, chose surfaces from sketch, highlighted all this, and then clicked generate to generate the surface. Once the surface was generated, I drew a light, just a large box over it to use as the actual wind tunnel. Again, I chose the dimensions and then made it 350 centimeters high and 150 centimeters long. So once that was done, we could go on to our meshing, which this is the result of the mesh here. So what we did was the automatic method of meshing. We changed the element size to 0.05 meters. So what is that? That's half a meter, half a meter, so a quarter meter. They have 34,000 nodes down here. I refined it to a level of 3, which is as far as you can go, apparently. I don't know why 3 is, or whatever. We did 3. And then generated the mesh. Go ahead and click that. Shouldn't do anything. Mesh hasn't changed at all. Once it was generated, we named all our sections, or I named all the sections. Inlet, outlet. Symmetry is just the top and bottom walls here. You got upper wall, which is this guy. You've got lower wall, which is this guy right here. And then front wall and back wall, front wall, back wall. We can click on them and it'll show you exactly where they are. I guess I should zoom out for those ones, huh? Symmetry, top and bottom, inlet, outlet, right? So if you want to name those edges, you'd click on this guy right here, the edge box. You would just right click on that edge. Sorry, you would click on that edge and then right click on the edge, and then you can create a name selection. So that's how we create the named selection. So now we got our mesh set up. We've got our plate here in the middle. Everything's happy. If we go back to our workbench here, we could then go into setup. Again, this is all set up already. I ran the simulation. We went from a laminar flow to a K epsilon flow, enhanced wall treatment, and we added pressure gradient effects on there, right? Down here, materials, we're just going to use air for our fluid. Boundary conditions, we messed with the inlet. I chose 5 meters per second as the velocity of the air coming in. I don't know why this box won't stretch for me right now. I did this earlier. We can scroll down here. This little tiny box here. Scroll over and you can see magnitude velocity in 5 meters per second. Cool. Give me 1 second here. Bubba, I'm finishing a project. Okay. So yeah, there's our velocity. We're going to input there. We have our shape in there. We didn't mess with outlet pressures, just gauge pressure, 0, atmospheric pressure. We didn't mess with back wall or any other stuff. We did change our reference values. We adjusted the area in meters squared to 0.5 meter squared and the length to 0.5 meter. And then we would come down here and we would initialize. And once you initialize, this little guy over here cranking away. That's not a toy, Bubba. It's not a toy. And then we would run the calculation. This one actually ran pretty fast when I ran it. So I'll go ahead and run it. The other ones after this, I felt like my machine was going to melt and spitting out really hot air. The fan was getting really angry. So while that's running, once it's done, we'd come down here to the XY plot. We'd create an XY plot so we could find a point of stagnation. And then we would look at our forces as well, so we can have a nice table of pressure and viscous forces acting on the plate. The dog is nonstop. We're nonstop. Cool, it's done. So that would be an example of running the calculation. If we look at our XY plot, we got one there already. We can create another one. We're gonna look at wall fluxes, and we wanna know what the wall flux is. Really, dude? Come on, man. Let me finish my project. Plot. There we go. There's our plot. Upper wall, we can see where the stagnation is. It's real close, right around the 1 centimeter mark. And down here, we look at the forces, and we want forces acting on all of them. You print that out, and you get it over here on the side. You want to move the console somewhere where we can actually see it. Stretch this out. So here you can see the forces acting on different walls. Split this in my report. If you look at the lower wall, there's no pressure at all. And the upper wall, there's just very, very little pressure going on right here. So if we look at the actual model or wind tunnel here, it's not perfectly centered. I think that's why there's a difference there instead of being 0 and 0. So if we look at the actual contour, nothing changed. I just ran the simulation, so that's fine. So this is our velocity contour. You get that by coming up here, clicking on this bad boy here, and then you would, I named it velocity vector, right? And then you could edit it down here, location, symmetry 1, that's everything. Factor, this is super cramped right now. We can change the factor to 5. It'll allow us to see it a little better on what's going on here. So we can see here, the air breaks around it. You get a boundary layer here, a little negative velocity area here that you can see better if we increase it to, or decrease it to like 2. You can really see it as it swirls around the back end of it here. Again, it's not exactly centered, which is why I think there's a difference between the two top and bottom pressures. So if we get rid of the velocity vector, we can look at a velocity contour. I use this button up here, set it up the same way as we did in the first assignment. Symmetry 1, we're looking at velocity. Did 50 contours. For the other simulations, I did 100. So let's go ahead and click that up to 100. Run it again. And you can see the velocity profile change here. It kind of looks like a little jet here in the back. So you have 0 velocity all the way up through the red here, which is 5.6 meters per second. That is velocity. Excuse me 1 second. Guys, knock it off. See a well-defined boundary layer around it here, right at the front, the leading edge, the top and bottom. And then back here, you have a really big boundary layer. A little bit of negative velocity, well, not negative because we don't have any negative velocity, but you can see it's just really small here. You can actually click on it. Use our probe variable, bing. So right here, we got 0.384 meters per second. That's our velocity right here. If we move it over here, have even less, 0.02 meters per second. If we get right up on it here, yeah, it's, I mean, to the -5. So what, 0.00005 meters per second. So, I mean, it might as well be 0 at that point. It's, you know, beyond the 3 sig figs that we like to use in engineering as far as that's concerned. So zoom back out here. That is our velocity contour. And we're also going to do a pressure contour. This is our pressure contour here, so we can see our different pressures. So if we take the probe here, you see here on the front edge where we have the highest pressure, it's a flat surface, so that air is going to just be hitting it and then stopping, and then that's going to build pressure there. As that high pressure area increases in size, it then creates a little bubble, which pushes the air around it. And that's where you get these low pressure areas right here. Excuse me again, I apologize. Guys, seriously, stop. Okay, they're gonna be staying on the porch for the duration of the video. So if we take our probe here, which is up here, oops, not quick editor, tools, probe, we'll drop this guy right here, probe variable here. You can see we have a -14 pascals as far as pressure is concerned. So, you know, that is a real low negative pressure area there, vacuum. Shit. Yeah. I don't mean to do that, I apologize. Real low pressure area there, vacuum, which goes along with the velocity profile because you have that vacuum there. So if we look at the velocity vector here and get rid of the pressure contour, you can see it, the air right here just getting sucked around it. And then here in the front, we've got our high pressure area. We're looking at 13.5 pascals. So those are our pressure areas for this particular particular run. So what we're going to do now is increase the angle of attack to 30 degrees, which is going to be our B here. So again, it's all done, but I'll walk us through it so that I get my grade. So same thing as before. This time what we did though, what I did was I drew a line. So using the line, I can just do a little down here and show you. Take the line, draw the line, right? And then you come over here, and you can draw another line. And then you can adjust the angle by dimensions, angle. Choose the top one first, the bottom one second. You get this little fun guy out here. Right? And this is angle 2. So right now it's at 30 degrees. I probably remembered it from earlier, but we could change it to 25 or, I don't know, 160. I mean, really, whatever angle you want, and that way you know you have the appropriate angle. So for this particular one, we did a 30-degree angle. From there, what I did was I continued to draw. I just drew a little rectangle. So if you click here, you draw your little line up here, right? You want to make sure it's straight. What's nice is this software will give you a little notification. Oh, perpendicular. Yes, that's what I want. And then we can go here. And again, you want it to be straight, but then as you get close to it, it's like, oh, you want it perpendicular and parallel? Yes. And then from here, you go back to that point, perpendicular, yes. So that would be our rectangle. Now this was messing me up earlier. I kind of had to figure out how to work around it here. So we have our box here, right? What we want to do now is we can just go up here and select. We select that guy and just get rid of it. Now you have your box, or your plate, I should say, at a 30-degree angle. And similar to before, concept, surface sketches, right? Apply, sorry. Box select. So that's our box, base objects, apply, and generate, and we have our surface there. So that's how we got that plate at the 30-degree angle. I just put this guy right here. Yeah, that's right. You have to come up here. Surface body. Suppress. So that's out of here. Then you would go back to workbench, mesh. I'm not going to redo the mesh because I drew that object in there to show. Here's the mesh, like we did last time. Automatic method, refinement. Did a 3 on the refinement. Oh, no, I didn't. Interesting. So let's go back and actually change this. I'm finding an error. Let's go here. Change the refinement to 3. Try to connection. Go. Here's our mesh. Mesh is generated. So here. Got our little recycle symbol, update. I think I broke the program here. Excuse me. Look at that, we're done. So setup, update. All right, so as we did before, viscosity or viscous here. It's done running, updating. Here's our guy. So viscous, again, standard, K epsilon, enhanced wall treatment, pressure gradient effects. We're going to go to the inlet. We're going to do 5 meters a second again. Velocity magnitude, 5 meters a second. Outlet pressure is just going to be 0. 0. Our reference values, we changed the area to 0.5 meter. Length, 0.5 meter. We'll initialize. And we'll run the calculations. We changed it to 1,000 iterations. I forgot to mention that on the last simulation, that it was 1,000 iterations. Go ahead and calculate it. Let it run. Is your simulation running? Better go catch it. Bahahaha. 990 iterations. Watching Ancient Aliens while this is running. And turn the computer on, you can watch it with me. Very exciting. Time space pull. I know I said I wasn't going to run any simulations at the start of the video, but found some things, changed some things, so we're going to run some simulations. That's why you can watch this in 2 times speed, 3 times speed. Right. Calculation complete. Look at that. So this is our 30 degree. Yes. Bunch of empty promises in this video. I'm not going to run simulations. I'm not going to let the dogs back in. Here we are, running simulations. The dogs are back in the house. Really? Really, dude? You can say hi to the camera at least? No? No? I'll try and crawl into my lap. No, Bubba. Come on. Get down. Down. All right, so we'll start with the pressure contour. Got our pressure contour here. We can see a high pressure region forming on the leading corner of the plate, while a low pressure region is forming on the second corner or trailing corner, I guess. We look at our tools here and go into our probie. Go right in here, probe the variable. We're already looking at pressure. Get negative 18 pascals in this area here, while up here on this side, look at it, it's 17. So what, here you got 17, and here you got negative 18, so that's a difference of about 35 pascals. So what we're seeing here is we're seeing the effects of lift. So this is kind of the same thing that when an airplane takes off, right, you got a contoured wing, and then it goes like that. You get this high pressure region here and this low pressure region on top, and the plane can fly. Of course, you can't do any of that without thrust. You need engines for that, and that's a whole other can of worms. So we're looking at the velocity here on our velocity contour. Holy cow, look at that. So the air is hitting the plate, it flows down, not a lot of change in velocity along here, and then right here it really picks up over here too. When we zoom out, you can see you got this region here where velocity really goes down, and you got this nice boundary layer that is kind of big up here actually. If we use our probe tool here and actually look at velocity again, right? Tools, probe. We have a very small 0.24 meters per second up here in this region. Probe up here, 6.8 meters per second. So that's actually a little bit faster than the 5 meters per second inlet that we started with. Way out here, this area, yeah, 6.8 still. And then back here, I mean, you can see this right here, probably really small, 0.077 meters per second. So less than a light breeze there. And then we can show our velocity vector here. A factor of 1, let's change that to 4, clear it up a little bit. And you can see that we have a negative velocity here, and these two little vortexes that formed as you have that negative pressure area up here at the front that creates a vacuum that's going to pull that air back into it. So that's the 30-degree attack angle and how to do that. So if we look at 60-degree attack angle now, same as before, do our geometry here in Design Modeler. So as before, drew a line, drew another line. Once those two lines were drawn, right, we went down to dimensions, angle, top line, bottom line, got our angle at 60 degrees. Dog's eating foam that he chewed out of a dog bed. Cooper, go lay down, Bubba. Go lay down. 60 degrees, and then continue to draw the box just using lines. Line, 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 and then dimensions. Or I'm sorry, dimensions. We changed it for length here. Oops. Changed it for length, so you can see here, L3, 50 centimeters. L2 is down here, 5 centimeters, and then the big box here, 700 centimeters and 300 centimeters. Again, once that's done, we did the meshing. We chose automatic method. Did this, did a refinement of 3. Named all the sections again: inlet, outlet, symmetry, top and bottom there. Front wall. I'll have to zoom in for this. This is front wall, back wall, bottom wall, top wall. Excellent. Generate the mesh. We did the mesh as a 0.05 again. Once the mesh was generated, we go to the Fluent here. You know what, that was the wrong one because we're talking about 60 degree here. So this is your 60 degree mesh here. I apologize. So you can see it. 5 centimeter or 0.05, right? Our refinement. Didn't do 3 here again. All right, so we'll run another simulation. Yeah, update. Cool. Mesh is ready now. Look at that. Look at that. All these little vortices and crazy stuff that's going to happen here when we run the simulation. That's fun. That's fun. All right. So now we got a Fluent. Right. It should give me an alert saying that things have changed, but it didn't. Everything's set up the same. Viscous, right? K epsilon, enhanced wall treatment, pressure gradient effects. And okay, and then reference values down here. Bing, bing. Everybody's happy. We'll go down here. We will initialize. We'll run calculation. And it's back and relax. Yeah. Okay. Writing. GSIC. And we're off. 134,000 nodes. simulations complete. All right, cool. Our XY plot. Look at wall fluxes here on the top wall. Save. Look at that. It's fun. It's definitely changed. So the position hasn't really changed. This is interesting. So let's look at our fluid flow here, because this is definitely gonna, I'm definitely gonna want to refresh this simulation here. Yeah, look at that, huh? That's fun. It's a little bit different. All right. Just got legend up here. All right, we can see our velocity. It's 17. Wow. So you got negative velocity here, 2 vortices. It actually causes another vortex here in the back of the tunnel. So we look at our velocity contour. So that's all changed. You can see these now illustrated, and then pressure again. A giant vacuum in the back here. The high pressure areas in the front. So, cool. So that's fun. And then last but not least, we have the 90-degree plate. This one just did a rectangle, kind of like we did before. Did a rectangle, got the dimensions I wanted, built a wind tunnel around it. Then did our mesh, which I had the refinement correct on that one, so we don't need to remesh it and run simulations here. And go to Fluent here, and we set everything up the same. Viscous, right? K epsilon, standard, enhanced wall treatment pressure gradients. Inlet is going to be 5 meters per second velocity. Which we're going to do this weird small thing and getting that's cool. Yeah, I don't know why it does this. Velocity specification method. So there's magnitude, velocity, magnitude, 5 meters per second. So that's that. Reference values have been adjusted to what we've been doing. And we would initialize and then run the calculation. So this one I did a bottom wall and top wall plot because this plate is at 90 degrees. I named what was the leading edge is now the top wall. Back wall was the top wall, front wall was the bottom wall, so on and so forth. So that's how it was named. Here's our pressure contour here. You can see it's similar to the initial one we did at 0 degrees, but because this one's at 90 degrees, you have a much larger pressure area here, negative pressure area. If we drop the probe in there and look at it, we can see negative 15 pascals. Yeah. And then in the front here, yeah, 21. So a difference of 36 there. So you can kind of see how if we like kind of bent this around and started to make like what we know as a wing shape, you get these big pressure differences on the bottom and the top. If we look at velocity, excuse me. Velocity here. Again, 0.24, even less, 0.07. And then here on the top and bottom, oh, it's more than I expected. 0.7, 0.06. Right on it, 0.06 of 0. So there's our boundary layer. So, all right, well, let me show you velocity contour. Here we go, a nice like nice effect here, like a trail. Let's see, from like a rocket nozzle maybe, and then our vector field. So there we can see this just giant stream of negative velocity or air that is going opposed to the flow, and then our two vortices. So thank you very much. Please, if something I did is not acceptable or is going to cost me points, leave me a comment so I know and I don't do it again, because don't want to keep losing points on these projects that we're probably all putting a lot of effort into. So thank you for your time, and look forward to the next project. This one was actually really fun once I got the hang of it. So thank you.